In this video, you're going to learn about sets of numbers and inequalities. With numbers, there is a way that we have to categorize different types of numbers. So we have what is called the real number system. And believe it or not, there's actually a thing that is called the imaginary number system. But that is for another lesson. So the real number system is really just everything that we use on a day-to-day basis. So it could include fractions, could include positive numbers, negative numbers, could include zero, could include things like pi, or like square roots of things that don't work out evenly, decimals that keep going on forever. Any sort of number that we use would be considered a real number. All right, so here is the categorization of the real number system. So under the real number system, we have both rational numbers and irrational numbers. Okay, rational numbers is anything you can write as a ratio or a fraction. So here we see -2. That would be rational because you can write that as a fraction. You could write that as -2 over 1. That is the same thing. Even 0. 0 over anything would be 0. So 0 could even be written as a fraction. That goes for 4 as well. 4 over 1 would be the same thing as 4. 4.5 you can write as 4.5 or 9 over 2. So that would also be rational. 1/2 is already a fraction, so that would make sense. And then 0.3 repeating, or 0.333, etc., going on forever. Even though it keeps going forever, this would actually be written as a fraction. And this would be 1 over 3. So any sort of repeating number, even though it goes forever, would also be rational. All right, that is as opposed to irrational numbers. Irrational numbers keep going on forever. So pi is 3.14159, etc. Keeps going on forever and ever. The square root of 4 would be a rational number because it's a perfect square that would equal 2. But if it's not a perfect square, like the square root of 3, the square root of 3 is going to be 1 point something, and that decimal is going to keep going on forever and ever. So the same thing with square root of 10. That's going to be some decimal, 3 point something, that keeps going on forever and ever. And then if you see a decimal with dots at the end and it's not repeating, that means it keeps going on forever and it doesn't repeat. So this would be irrational because the decimal goes on forever and ever. All right, so we have rational versus irrational. Under rational, we have specific types of rational numbers. So under rational, we have integers. Integers would be basically anything you'd see on a number line. Right, on a number line, if you were to create one, these little tick marks would have just like 0, 1, 2, etc. And on the negative side, you have -1, -2, -3, etc. Whatever you'd see on these little tick marks right here on the number line, that would be an integer. So any negative number without fractions written, 0 would be an integer, and positive numbers without fractions would as well be integers. All right, and more specifically, under integers, we have what's called whole numbers. So whole numbers are also integers, and they're also rational numbers, but more specifically, whole numbers start at the number 0 and go up. So 0, then 1, 2, 3, 4. Once again, no fractions, just the whole number. And the way to remember that whole numbers start at 0 is that 0 literally looks like a hole. So a different type of hole, not the W-H-O-L-E hole, but 0 looks like a hole. All right, so that's where it starts for the whole numbers. The natural numbers would be a type of whole number, and they'd also be an integer, and they're also rational numbers. But more specifically, natural numbers start at the number 1 and work your way up to infinity from there. And maybe a dumb way to remember this, you think of babies. Babies are born au naturel, and when you teach a baby or a small child how to count, you're going to begin with 1. Right? You go 1, 2, 3, etc. So that is your natural numbers. And the symbols, by the way, for the different types of numbers are given here. The symbol for rational numbers is a fancy Q. For integers, it's a fancy Z. Whole numbers, you have W for whole, and then N for natural. Now that we have our number system in place, there are different ways that we can compare the size between two or more numbers. So we can use an equal sign to show that two numbers are equal, or we have what's called an inequality symbol to show that two numbers are not equal. So the prefix in means not, and then equality, you see the part equal, so this literally means not equal symbols. So these are symbols to show that two values are not equal. So one inequality symbol would be our less than sign. So this sign here means less than. So for example, 3 is less than 8. All right, this would be stated in English as 3 is less than 8. The other sign right here means greater than. So using the same numbers 3 and 8, we could say that 8 is greater than 3. All right, so notice that the mouth is facing the bigger number. So if you can imagine this as being like a little Pac-Man or something. So the Pac-Man is always hungry and wants the bigger number. So the mouth faces the bigger number, which in this case is going to be 8. Even if the 8 moves to the left side, the mouth still faces the 8. All right, and then a way to remember which symbol means less than and which one means greater than. The less than symbol kind of looks like the letter L, so L for less than. Another way to remember is that this symbol here, if you imagine this as an arrow, an arrow pointing to the left, points to the left, so L for left and L for less than. So those are different ways that might help you to remember which one means less than and which one means greater than. So here are a few quick true and false statements, and you are told to determine if these statements are true or false. So here we have 0, and then this symbol, and then 8. So this means 0 is less than 8. The mouth is facing the 8, so that is a true statement because the mouth needs to be facing the bigger number. Here, the mouth is facing the 4, which is bigger than 3, so that would be also a true statement. That would be 4 is greater than 3. Now what about this one? So this one, the 3 is bigger than -1. The mouth is facing the correct direction. It's facing the bigger number, so that would be true. And this would be stated as -1 is less than 3. Here is another statement. Is this one true or false? Well, notice the mouth is facing the smaller number. It's supposed to be facing the bigger number, so this would be false. And this would be stated as -2 is greater than 8, which is not a true statement. Okay, what about this one? Well, the -1 is actually bigger than -5. -5 is smaller, so the mouth is facing the bigger number, so that would be a true statement. Okay, here we have another one. Is this true or false? Well, -3 is actually bigger than -4, so the mouth should be facing the -3, so it's the wrong direction, so this would be false. What about 1/3 and 1/2? Well, this one would be a true statement because 1/2 is bigger than 1/3, and the mouth is facing 1/2, which is correct. Also, it's important to know how to convert into math notation. So here we have a statement. -2 is less than 4. if you had to write this in math notation, the less than would be this symbol, and then we just write the numbers -2, there's a 2, and then 4. So -2 is less than 4. Okay, 4 is greater than -2. To write this one, we have a 4. Greater than would be that symbol, and then -2 written over there. All right, here we're going to learn a few more different types of inequality symbols. So here's one that is a little bit new. Here the statement is x is greater than or equal to 3. So we have two different things, x is greater than 3 or x is equal to 3. Well, there's a symbol we can use to express this statement. So instead of writing out, x is greater than 3 or x is equal to 3, we can write this together as one statement. So we write the x and the 3, and we have the greater than sign, and then we don't take the entire equal sign, but we're going to put just one of the lines here and write it like that. So we can express this statement as x with this little symbol in between, and then 3. So this literally means x is greater than 3 or x is equal to 3. All right. Another statement would be less than or equal to. So if I were to say x is less than or equal to 3, this literally means x is less than 3 or x is equal to 3. So I can once again combine this into one quick statement where I have x and 3, and then I take the less than sign, and then I take just one line of the equal sign, and I get this statement right here. So that would be written mathematically right there, x is less than or equal to 3. And in English, we can think of that as two statements, x is less than 3 or x is equal to 3. One more inequality symbol that we have is something that's not equal to something. So for example, 4 is not equal to 7. So the word not, we're going to take our equal sign and put a line through it to represent not equal. So in math notation, we would write this as 4, then this equal sign with a line through it, and then 7. So make sure you can express each of these different English statements in math, and make sure if you see the math statement that you understand what it means in English. Now let's finish by getting some practice with these concepts. So true or false? Is 3 greater than or equal to 3? So as long as one part of this is true, then we have a true statement. Because this is two statements, right? This literally means 3 is greater than 3 or 3 is equal to 3. Alright, well 3 is not greater than 3, but 3 is equal to 3. So as long as one of these are true, we have a true statement. So that would be true. Next we have 4 is greater than or equal to 3. So this literally means 4 is greater than 3 or 4 is equal to 3. Well, 4 is not equal to 3, but 4 is greater than 3. So that part is true, which makes the whole statement true. So my answer is true. Next we have 5 is less than or equal to 5. So this statement literally means 5 is less than 5 or 5 is equal to 5. Well, 5 is not less than 5, but 5 is equal to 5. So that part is true, which makes the whole statement true. Alright, next we have 4 is less than or equal to 5. So this literally means 4 is less than 5 or 4 is equal to 5. Well, it's not equal to 5, but it is less than 5. So therefore, this would be a true statement, not false. This is a true statement. Now here you are asked which numbers are members of the solution sets for the following inequality. And you're given 8 is greater than x over 2. And your choices for x would be 14, 16, or 18. So to answer this question, I need to plug in 14, 16, and 18 in place of x to determine which ones would give me a true statement. So we can begin by plugging a 14 in for x. So instead of 8 is greater than x over 2, we would have 8 is greater than 14 over 2. So 14 over 2 is 7. So we'd have 8 is greater than 7. Now is that a true statement? Well, yes. 8 is bigger than 7, so 14 would work. Next we plug in a 16 for x. So we have 8 is greater than 16 over 2. And this would be 8 is greater than 8. Now is that a true statement? Well, no. 8 is not bigger than 8, but 8 is equal to 8, but that's not what the question says here. So 16 does not work when I plug it in. So 16 is not an option. And then we plug an 18 in. So now we have 18 over 2. So we have 8 on the left, 18 over 2, which is 9 on the right. Is 8 bigger than 9? Well, no. So this would not work as well. So my answer should be 14. So not 18, but 14. All right, now if we have the same question and same choices, the only difference is our sign is 8 is greater than or equal to x over 2. So everything we just did is the steps we need for this problem as well. The only difference is the sign has an equal sign. So if I take all of the work we just completed and put an equal sign with it, the question is which ones would give me a true statement. All right, so here, the first one, 8 is greater than or equal to 7. That would still be true because 8 is greater than 7. It's not equal, but it's greater, so that would work. So 14 would work for that one. And then 16. So looking over here at the second part, plug a 16 in, we'd have 8 is greater than or equal to 8. So is this a true statement? Well, 8 is not bigger than 8, but 8 is equal to 8. So therefore, 16 would work, and it would create a true statement. So 16 is a solution. And then here, for the third one, 8 is greater than or equal to 9. Well, 8 is not bigger than 9, and it's not equal to 9, so 18 still would not work. So my answer for this one would be 14 and 16. And that concludes our lesson for today.